Mm.
Yes, sir. For 2 minutes, sir.
Yeah.
Hello, everyone. Hello, everyone present here virtually. I am Sweetie here, and I welcome you all for today's session, which is a title as Choosing Best Analysis in Scientific Research. And presenting these sessions, we have with us our today's expert, Hazar Belbas is a lecturer in Statistics Department in College of Administration and Economics at Salahuddin University. Early, he against his bachelor degree in Statistics Department at Salahuddin University, and he was the third student among 132 students with average 85.516 in 2007. You can start now, sir.
Yes. Thank you so much. Thank you so much for your time. Hello, everyone. Hope everyone doing very well. Today, I'm so proud to be here to discuss one of the session about choosing the best analysis in scientific research. I would like to thank the research circle who they invite me to present this seminar or to this webinar. First of all, I'm going to say something about the Carl Pearson, which is one of the famous statisticians. He said, statistics is a grammar of the science. It means everyone can understand what the statistics, what the number. That's why he called this is the grammar of the science. There's a lot of process of data analysis in scientific research, but I'm going to follow some steps that which is interesting for me. First of all, if you want to do the research, you have to have a problem of phenomenon. Once you have the problem, you need the data. How you're going to collect the data, the info about this problem that you're going to search on it or work on it or undertake on it. And then you have to organize the data, and then you're going to analyze the data, and then you get some decision. I'm going to follow these steps one by one today separately. First, what's the problem? What the phenomenon? Everyone familiar for the problem. If I said divorce, yeah, of course, of sure. This is one of the problem in most of the country. Most of the people, after they get married in a while, they're gonna divorce for some reasons. Now we're gonna do the search. Why they're gonna divorce? Okay, but divorce is not the whole title. It's not the whole scientific research title. I'm gonna add something such as reasons for divorce. It's much better, but not quite. Statistical analysis for the most influential reasons for divorce is much better. If you said statistical analysis for the most influential reason for divorce between men and women, now I did some comparison between the males who get divorced, the women who get divorced. And now in the finally, statistical analysis for the most influential reasons for divorce between men and women in herbal study in Iraq. Now I make some specialize or some specially for this research which is going on in Erbil city, which is one of the city in Iraq. Now I could say this is the full topic, this is the quiet topic, and then if I have a topic, I have to decide to collect the data in that topic, in that problem. The process of the collecting data, it's a really long process. I'm gonna follow some steps in here. Define the population, which is really important. Without the population, it's not easy to take out the sample. Once you have the population, you have to choose the sufficient sample size, especially you can use Cochrane formula. And then which sampling you're gonna use it, which source of data collection you needed, which method is the best for your data collection. If you need the questionnaire structure, you have to create the questionnaire and then distribute it and then collect the data. We're gonna discuss this part in later. Pilot test or pre-test. Okay, before you are distributing the form, you're gonna do some pilot test. Calculate the sufficient sample size. It said before requiring participation, decide on your sample size either by. It means before you are distributing your form, you have to decide how many sample size should be in your research, in your work. How are we going to do this? Looking for at other studies. It means the previous study in your field, okay, to see how many they use it, how they work on it, and so on. Or you can using statistics. Sample size should be representative and unbiased of the population. Why? If you collected a lot of samples, it's gonna take the cost for it. It makes costly, which is not good for you. You don't need to spend more money, more money. If you take a small number of sample size, it's not gonna represent the entire population that you have. That's why always, you're gonna focus on it. The sample size should be representative and unbiased of the population. There is one example about the smartphone for adults in the United Kingdom, UK. Suppose that it wanted to estimate the proportion of the adults who have on smartphone in the UK. It means UK is a really large population. We don't want to use all the UK population as our work. No, just we're gonna focus on who has or who have a smartphone. Okay, just the adults who have a smartphone. For example, from one sample, people that have been taken, we said 95 out of 100 people have on smartphone. It means our work in here is not for 100 people. No, just we're gonna work on 59 people or 59 adults who have smartphone out of 100, because this is our target, this is our goal. Just we're gonna work on those adults who have a smartphone. So now we can estimate the proportion, which is really important to take out the sample size. 59 divided by 100, it means 59% or 0.59. Always we're gonna concern about the uncertainty. Uncertainty is really one of the most important part in your research. Always you want to reduce uncertainty. But how are you gonna reduce uncertainty? By reducing the margin error. It means declining or decreasing the margin error. It's gonna give you more certainty in your sample size collection. For example, 95 confidence interval for our estimate based on our sample of 100, as we talked about it, ranged from 49.36% to 68.64%. It means these of those 59 adults who have smartphones should be ranged between 49.36 to 68.64. This is the two Cochrane formula, and now this is the, we can say this is the elementary formula without the number of the population. Just we have the z-score proportion, 1 minus proportion, divided by margin error squared. But the second one, this is the advanced one, because it has the number of population, including these info. For example, if the z value equal 95% confidence interval or confidence level equal to 1.96. 95%, it means 5% of the error, type 1 error, okay? It means 95% your work would be contains in these two limits, upper limit and lower limit. It's easy to find this score if you take out 95 confidence level, 99 confidence level, 97 confidence, and so on. Okay, there's a table, you can search it and easy to find it. Estimate of the proportion, as we said, the proportion is really important in your work. Once you want to do any research, you have to search it. What's the exact proportion in your title in your population? It's not all the population that you are working on it. As we said before, for the smartphone, just 59 people, they have the smartphone. This is your proportion. It's not 100%. Just you're gonna focus on it. Who have it? Who work or who use the smartphone? If you couldn't see this or if you couldn't find it, you can use 0.5. It means 50%. Even if you couldn't in your previous research, in your any related work that they did before you, or it's not easy to find in your population, so you can use 50%. Margin error, most of the statistician or researchers, they're going to use 5%. If you reduce the margin error, your certainty would be more and higher. Then, for example, the number of the population in here is 1,000. If you have this info, the sample size would be 278. Some of the researchers said it's not easy to use this calculation. You can use any online formula or online tool. For example, this is www.calculator.net/sample-size. If you just put this info in that or in these blankets, you're gonna give you the exact sample size as we had before, 278. It's easy. By one click on the Google, you can search and find it. Once you have the number of sample size, you have to choose which sampling is the best for you. You have two types of the sampling: probability sampling and non-probability sampling. Probability sampling, it means each element, each case, each person in the population has an equal chance to be selected. You have these four types: simple, stratified, systematic, and cluster. Non-probability, every element, every case in the population doesn't have equal chance to be selected. It means in here there is no randomization. You're gonna choose who would be in your team, who would be in your research work. You're gonna decide it, okay, as a researcher. We have four common types: convenience, judgment, quota, and snowball. Definition of the data. This is one of the important things in here. It said data is a universal language, a global language, allowing the scientists to work together. It doesn't matter where they are, where they work, where they live, but the important thing, we're gonna work together for one problem and get some decision from that problem, and we're gonna distribute to other. That's why data is really important, and they said this is the global or the universal language. Why data is important? American said garbage is garbage. So it means if your data is wrong, of course your result will be wrong, your conclusion will be wrong, and your research or your work would be meaningless. That's why you have to focus on it. You have to collect the exact data that you needed on your work. Understanding in that permit. Data. If you said 100, sure, 100 is a data. But if you make more clear how it become information, if you said 100 miles, we add something in here. If you say 100 mile is a quite for distance, we discuss about the distance. It's really wrong. It's not easy to 100 miles. That's why it's a quite or it's long for a distance. It becomes a knowledge. How it becomes it's a wisdom? If you said it's very difficult to walk 100 miles by any person, but vehicle can do this. That become a wisdom. We have two types of the data: qualitative data and quantitative data. Qualitative data, it means it contains or is a character that contains numbers and text. Nominal, these numbers, that these text couldn't be arranged from the smallest value to the largest value, like gender, male, female, favor of the food. Ordinal, also this is the character that contain text and alphabet, but it could be arranged from the smallest value to the largest value, such as level of the education, primary school, secondary school, high school, and so on. Quantitative data set, this is the character that contain different values, numbers. And here there's a number, there's no text, no alphabet. Discrete, it means exact number, like age 25. We couldn't say 25.3 months. For example, number of family, 7 member in that family. It's not possible to say 7.3 member in that family. No, it's not logical. Continuous, it has some decimals, some pointers, like weight. We can say I am 61 kilo point 30 grams, and so on, or height, or and so on, or temperature. Source of data collection, you have two sources. Primary source data, it means you're gonna collect the data by your own self. You're gonna do it as a researcher, okay? It means you're gonna create the questionnaire form and then distribute it to the people who want to work on it from the population that you have been decide to work on it, and then return back this form and you become our own data. Secondary source data, or someone said historical source data, this is the data that have been collected before you, and you're gonna reuse it by their permission. You can find it in any scientific book, in any research paper, thesis, dissertation, or any director. You can find that data as a secondary source data. Method. We have several methods for collecting data: face-to-face, online, mail, phone, and so on. Most of the researchers suggest us to use mixed mode. For what? For saving time and getting a lot of participants sooner. For example, you can use face-to-face with online, or online with the mail, or phone with the face-to-face. Which one is the best? We couldn't say which one is the best. It depends on you. Depend on you as a researcher. You can decide, depend on your title, population, sample size. You're gonna decide which one is the best for you as a data collection method. How are we gonna construct the questionnaire form? Questionnaire, it's more art rather than science, because it's gonna take longer time that you thought before you started. It's gonna, for example, I said, okay, I'm gonna finish it in 2 weeks, but it's gonna take 1 month or more than. That's why it's more art than the science. How we can start it? Okay, first of all, it's really important to write down the cover letter. Cover letter is really one of the important things on your questionnaire form as a researcher. Why? If you say, my name is, I'm working in this university, I'm gonna do the research in this title, your time is really important for us. All your answer would be secret, and just we're gonna use it as a researcher for our research, and so on. If you write down such a words like that, the responder gonna believe you that you are a scientific man or woman, believes you that you are not a spy, and the responder feel more comfortable to give you the exact or the correct answer. That's why you have to write down the exact or the proper cover letter in the top of your questionnaire form. In the end, just say thank you so much for your time. I really appreciate your time, and so on. We have two types of the question: closed format and open format. Closed format, you're gonna push the responder to choose one of the options. Multiple choice, for example, yes, no, neutral, strongly agree, neutral, disagree, strongly disagree, as mentioned, like a scale. You can use such like that. It's really easy for the responder to click on it. I'm going to choose this one, second one, third one, and so on. For you as a researcher, it's easy to code it, to recode it, to analyze it, and so on. Easy to report. How about the open format? Open format, the responders are free to answer whatever they want. There is less restriction, okay? Allow the responder to deeply think about these questions and answer, but it's gonna take the time for them to think about what's the exact solution, what's the exact answer for that question. That's why it's gonna take more time that they expect. You can use it for, if, for example, if you want to get the feedback from the student, you can use this one. If you want to get the feedback from the restaurant, from the hotel, from the marketing, you can use such a open format because you wanna see what the client talk about, or their opinion about that restaurant, that hotel, and so on. There is some demographic or really important questions on your uh, questionnaire form. I'm gonna suggest you as a statistician, do it as an open format like age, experience, year, feedback. Why? Because if you open age, if you write down what's your, how old are you, your age, and blanket is a open format, they're gonna put their age. This is one of the quantitative variable, one of the scale variable. You can use it in the future once you go to the analysis part. It's really important if you have such a quantitative variable. If you decided to transfer to the categorical, like make some classification from age 20 to 30, 31 to 40, 41 to 50, 51 to 60, and so on, it's easy by 1, 2 clicks in any program like SPSR, SAS, and so on. You can transfer it from the quantitative to the qualitative, but as a statistician, I'm gonna suggest you to put it as an open format. How do I ask the questions and the entire questionnaire? Make simple and short. Follow the KISS method. KISS method means keep in short and simple for every single questions on your forum. Ask only one piece at a time. For example, don't say, please rate the global environment class in terms of content and presentation. No, just say, please rate the class in terms of content. Please rate the class in terms of presentation. Presentation, not together, because the responder confused. What do you talk about? What do you want? That's why you have to separate out such a questions like that. If possible for you, please don't write down any negative questions. Make the positive questions as much as you could. The question should be relevant to your main subject. It means it be related to your topic. Questions should be logical order from the easiest to the largest, from the closed format to the open format. Why are you gonna put the closed format in the beginning? You're gonna attract them to answer some of the questions. When they answer some of them and they got some open, or they said, okay, I did this part, I'm gonna do this part also, okay, but not revise. Open in the face and close in the back. No, I'm not gonna suggest you such like that. Personal questions should be avoided. Okay, for example, your title, it doesn't talk about the salary. Why are you gonna put, okay, your salary, your monthly salary? No, you don't need such a question like that. Please be careful, okay? Because the responder, they are really smart. They know what you're gonna do it. The words of questions should be proper without any hurting. Okay, you have to be careful. Questions should be covered, all the title that you have it. Okay, if you need 20 questions, just write down 20, no more and no less. Secret information should be sought. Question featuring like yes, no are preferable. For example, sometimes said, are you smoking? Yes, no. You don't need to say maybe, no. Don't put such like that. Just yes, no. Do you have the cell phone? Yes, no. Do you have a driver license? Yes, no. Pilot test is really important. Before you are distributing all the forms, you have to do the pilot test to see what's the uh, to see is your questionnaire reliable or not. We're going to discuss later. Pilot test. Pilot test of the survey to a smaller sample is suggests if possible. It means, for example, your sample size is 500. I'm going to choose 20, 18, 17 forms. Okay, I'm going to distribute it and then return back to see if there is any shortcoming, any mistake, any misunderstanding, and then I'm going to distribute all of them. Not once I distribute all the 500 and see, oh, what they respond to me. These are not qualified data. So that's why you have to do the pilot test or pre-test. The pilot test allow you to revise all the questions. For example, you put one of the questions, you know, most of them, they should say, yes, strongly agree with this, strongly agree or agree. You see, all the respondents said neutral, neutral, neutral. Neutral, it means they don't understand. That's why they put neutral. That's why you have to revise your question. Some of the questions you see, the open format is not gonna work for you, that you have to transfer to the closed format. Variability, okay, also it's gonna allow you to discuss to your friends. I have this form, this is my pilot test, and these are the frequency that I got from the pilot test. I got these results. What's your suggestion? Okay, your partnership, your friend is gonna give you some important pointers to make a stronger questionnaire form. Also, you can take the reliability test using Alpha Cronbach. Okay, if less than 0.6, you have to revise some questions or add some questions or delete some questions and so on. Organize data. This is really important step on your research to organize the data. If you have the questionnaire form, you're gonna put the ID for each of the questions separately and put it in one place. Data and coding. Remove the duplicate case. You don't need any duplicate cases. Okay, for example, some of the researchers come to my office, they said, I have 100 cases. Could you make double to 200? What's the beneficial point for that? No, don't make something which is really gonna reduce your certainty in your work. It's gonna reduce your reliability in your result and so on. No, you don't need to make duplicate. Even if you have a duplicate case, you have to remove it. Remove incomplete cases. If you see any incomplete case, you can remove it. Find the outlier because the outlier is going to affect your result in most of the tests in statistics. Find the missing data. If you have any missing data and you can solve it, do it. You can solve it. Find it. Data should be cleaned and error-free. If you have any transformation, you can do it before you go to the next step, which is data analysis. 60% of the scientists said this is not easy step. Okay, it's gonna takes a lot of time for the cleaning data, for organizing data, for the coding, and so on. 57 of them, they said this is not the enjoyable part. This is not the enjoyable. Of course, this is not the enjoyable because you have to clean it, you have to code it, you have to organize, you have to do such, blah, 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 till prepare everything to analysis. It's like the machine, okay? You're gonna do it step by step. If you have some assumptions, you have to be careful for the assumptions, okay? Especially when you do the hypothesis test or regression, correlation, and so on. Linearity, normality, symmetry, and common observation. Also, you have to do it. And then you're going to go to the next step, which is analysis of data, analyze the data. Once you go to this step, everything should be ready. Okay, from the title, data collection, organization data, and then you can go to that step. Data analysis, I'm going to read it, means a process of cleaning, transforming, and modeling data to discover useful information for business decision making. It means you're going to get some decision from the result that you get from where? From the population. In which population? In that population, you take out the sample. This, depending on the sample, you're going to get some result. And then you're going to decide or estimate from that population that you have. To make easier, you can use any program like R, SPSS, SAS, SQL, MATLAB, Minitab, Java, and so on. Goals. What's the goals for data analysis? Gonna give you the pattern of the data. Each of the data is gonna give you the pattern for that data and that one and that one and so on. It's gonna give you to see the relationship between two variables. You can make the comparison between two variables to see what's the difference between two variables. Cause and effect, prediction or forecast for the future. We have two mainly methods in statistics for data analysis: descriptive statistics and inferential statistics. Descriptive statistics means you're going to summarize the data. You're going to describe the data. How? By frequency table, charts, measures of central tendency, and measures of dispersion. It means you're going to use one of them, or two of them, or three of them, or all of them to describe your data set. From here, for example, I have 494 people who get divorced in this research in 2017. If just I create the frequency table, it's gonna give me easily the percentage of female who get divorced is higher than the percentage of males who got divorced. It's really simple but important. If you make the comparison between two variables, such as gender and level of education, you can see level of education with the men and women. Okay, there is a comparison. For example, literate, it means they couldn't read and write. In here, if you look at, they are the percentage of men is higher than the percentage of female. For elementary, the percentage of female is higher than men. For the secondary, the percentage of men is higher than women. For high school, the percentage of men also is higher than female who get divorced. More than high school, the percentage of women is higher than the percentage of male who got divorced. If you transfer this one, this frequency table to the chart, okay, we know this is the qualitative, okay, because male and female is a qualitative. That's why I have to create the bar chart. Also, this bar chart is going to tell me the exact what we have in the frequency table. Line chart. If you have a bunch of the year or the series of the years from 2008 till 2017, and the percentage in here from the y axis, I'm gonna draw the line chart. This line chart gonna show up the percentage of divorce between USA, Iraq, and Kurdistan. If you look at from the entire years, the percentage of USA higher than the percentage of people who get divorced in Iraq and the percentage of people who get divorced in Kurdistan, uh, respective. Respective. It means, I'm sorry. Okay. Most of the people they got divorced from USA from 2008 till 2017, followed by Iraq, followed by Kurdistan. If I'm just a little bit talk about the Kurdistan, if you look at here, from the beginning year 2008, the percentage are stable from 2008 till 2009, and then decline, and then a little bit stable. If you look at from 2013 till 2015, there is a gradually increasing the percentage of divorce. Why from these 2 years? Because the Daesh ISIS coming to our region, and also there's a lot of people or employees got jobless, and it's not easy to find out the job and blah blah blah. That's why the percentage of the divorce got higher and higher from that 2 years. Inferential statistics. In here, there is a process of estimating population parameter from the sample of the statistics. It means you're going to take out a sample. Depending on the sample, you're going to get some result, some decision, and then you're going to decide or estimate what's going to happen from the population. It means the samples going to decide what's happened from the population. That's why the sample size is really important. You have to be careful once you collect the data to collect the representative sample size. Hypothesis test, if you said hypothesis, it means you're going to compare the mean, the average between one group with a specific value, or between two groups, or between three groups, or more than three groups, and so on. We have these kind of tests in here for the hypothesis. Chi-square test also, there's a relationship, there's a correlation between two nominal data, such as smoker, non-smoker, diabetes, no diabetes. Okay. Correlation regression in here. Correlation, it means you're going to find the association of the correlation between two variables. Regression, you're going to see how much the independent variable going to affect the dependent variable. We're going to discuss these later. Factor analysis. A factor analysis, if you have a lot of variables, you're going to make some common clusters or factors. In each factors, you're going to put some variables. For example, if you have 40 variables, divide to 6 factors. Each factors gonna contain some variables. The variables who contain in the first factor, they gonna relate it in each other, but they don't gonna relate to the variables who contain in the second factors, and the second factors don't gonna relate to the variables who would be in the third factor, and so on. Time series analysis and Excel. Chi-square. From here, what you're gonna do, you're gonna see the association between these common causes or reasons for divorce: second marriage, stingy dominance, couple parentis, infertility, modern technology, with the gender, men and women. If you look at gender, is the qualitative data, men, women. Second marriage, stingy, and so on, they are also qualitative by using 5-point Likert scale: strongly agree, agree, neutral, disagree, strongly disagree. And if you look at it, there's a frequency for each of them, also the mean, okay? But I'm gonna focus on the frequency because I've used the chi-square test. If we look at for this info, all the p-values are less than 0.05. It means there is a relationship between all these causes, such as second marriage, stingy, dominance, couple parents, infertility, modern, with the gender. I mean, there is a difference. There is a relationship between each of the reason with the gender. Once you know, depending on the p-values, which is less than 0.05, you're gonna see which one more effective, which one they got more or highest percentage, men or women. If you look at here, from the first 5 of them, second marriage, stingy, dominance, couple parents, and infertility, the number of women higher than the number of men. Why? 286 to 08, 282 to 12, 278, 206, 264, 230, 289, 205. It means the frequency for women higher than the frequency for men for divorce for all of these second marriage, stingy, dominance, couple parents, and infertility. It means most of the women, they decide these are common causes rather than men, except the men said modern technology is more cause than the women said that, because the frequency for men is higher than the frequency for women in modern technology. It means depending on these 7 causes, just the modern technology would be a reason to divorce by men people. Others would be reasons by the women's people rather than the men's people. Independent sample t-test or one way ANOVA. Independent sample t-test means you have 2 variables, they are independent. We have followed the assumptions. For example, the data should be scaled, normally distributed, and randomization, and so on. You have to check it, okay? This is another paper. In here, we have overall depression. And here we have the gender. Because the gender has 2 branches, just male and female, that's why we have to use independent sample t-test. Overall, with the age, because age it has more than 2 branches, there's a 5 branches, that's why you have to use one way ANOVA instead of independent sample test. Once you do all the calculation and got the result, you're gonna look at the p-value. The p-value for the gender is significant. For the age is not significant, because it means there is no association between overall depression and age in that paper. But there is a significant association between overall depression and gender. If you know there is a significant association, you're going to look at the mean to see which one have more depression. If you look at here, depending on the mean, the depression of female is higher than the depression of male in that title, which talk about the phenomenon of depression and anxiety related to the question of the prevention among population during the outbreak of COVID-19 in Kurdistan as a region of Iraq. It means the women got more depression than men in that research. Correlation. This is one of my book. I found one of the example. The example is, before I'm talking about the example, I will say we have three methods of correlation: scatter plot, Carl-Pearson, and Rank-Spearman. Correlation, it means, is there any relationship between two variables, between the independent and dependent variable or not? Scatter plot, you're going to draw the graph to see what the relationship. Carl-Pearson, both data should be scaled, and then you can find the correlation. Rank-Spearman, both data or one of them, if the both data scale, you can use Rank-Spearman. If the both of them are ordinal, you can use Rank-Spearman. If one of them are ordinal and the second one is scale, also you can use the Rank-Spearman. For example, if you have age and systolic blood pressure. Age is an independent variable. Systolic blood pressure is a dependent variable. You want to see if you increase the age, what the systolic blood pressure would be. If you find the correlation, you see 0.99. It means there is a strong positive correlation between age and systolic blood pressure. It means increasing age would be increasing the systolic blood pressure dramatically. Okay. For info, the correlation would be between -1 and +1. This is the range for the correlation. Once you know there is a correlation, even a weak correlation, you can do the regression, but you have to follow these assumptions: linearity, independent of the error, normality, and equal variance. Age and systolic blood pressure. Age is an independent variable. Systolic blood pressure is a dependent variable. It's really important to know which one independent, which one dependent variable. Independent variable is always going to impact on dependent variable. If we do all the calculation here and we got this info, systolic blood pressure equal 81.29 plus 1.63 H. What's it going to tell us? It means increasing age would increase the systolic blood pressure. Positive correlation between age and systolic blood pressure because there is a positive sign. Okay, another important thing, increasing 1 unit of age would increase the blood pressure by 1.63. 1.63. Here, increasing 1 unit of age will increase blood pressure by 1.63. If you put 10 in here, it means 10 times 1.63 would be added to the blood pressure. Thank you so much for your attention. Hope you like it. Hope I gave you some beneficial point about the data analysis process.
Thank you so much, sir, for such a nice presentation. If someone have any questions, you can ask now. We have another 2 to 3 minutes. Hello, sir.
Yes,
Javerian man
yes.
was asking some
Okay,
questions. Why
okay,
we us inter items result?
okay.
Why we use inter item results?
Inter,
Item results.
what do you mean, inter item result? Excuse me, what do you mean?
She is asking why we use inter item results.
Excuse me, this is not clear for me, inter item result. I'm sorry about that. Could you write down on the chat box, please?
Yes, sir. Yes.
Yes, please. Excuse me, this is not clear for me. I'm sorry about this. I don't know what you mean inter item result. Uh, I do apologize for that question.
Okay, sir. Okay, sir. No problem.
You're most welcome.
Okay, so guess that if for today's sessions, I would like to thanks all the participant present here via research circle, all via YouTube and Facebook live. Last but not the least, thank you so much, sir, for taking out the time and delivering such a nice sessions with us with the due permissions of today's speaker. I would like to end the sessions here. Thank you all again.
Thank you so much for your time. Thank you.
Thank you, sir.
Thank you.